Welcome to my channel. In this video, we are going to study NCERT Class 10 Maths Chapter 1 Real Numbers. Some important examples. Let's start. Prove that 105 is irrational. Answer. Let's assume that 105 is rational. Therefore, 105 equal to A upon B. Squaring both sides, value 5 equal to a square upon b square. Then cross 5b square equal to a square, number 1. Then 5 divides a square here. 5 divides a square and 5 divide a. Reason, since 5 is a prime number and it divides a square, therefore it must divide a. Then where k is integer, so here a equal to, let a equal to 5k, where k is an integer. Squaring both sides, here a square equal to 25k square. Then substituting equation number 1, equation number 5b square is equal to a square. Here 5b square, a square means 25k square, so b square equal to 5 divide 5 5 25 k square, number 2. Then here 5 divides 5 divides b square, therefore 5 divides b. Reason, since b is a prime number and it divides b square, therefore it must divide b. Thus a and b are both divisible by 5. A and b, here a 5, b also 5. So thus a and b are both divisible by 5, which contradicts the fact that a and b are co-prime. Our assumption is wrong. Therefore 105 is an irrational. Second one, prove that 100p plus 100q is irrational, where p, q are prime. Answer. Let's suppose that 100p plus 100q is rational. Let 100p plus 100q equal to a, where a is a rational. So therefore 100q equal to a, this minus 100p. Then squaring both sides, here for information, so 100q bracket square a minus 100p bracket square. Then solve, value q, here a minus b bracket square equal to a square minus twice ab plus b square. So expand a square minus 2a 100p plus value p. Then this value put here, so minus here plus 2a 100p equal to this a square plus p and this minus q. Then 100p equal to a square plus p minus q upon this 2a, which is a contradiction, as the right hand side is rational number, this one, and while 100p is irrational. Therefore 100p plus 100q is irrational. Number 3. Prove that 3 plus 205 is irrational. Answer. Let us assume to the contrary that 3 plus 205 is rational. So we can find co-prime integers a and b equal to not 0, such that, so here 3 plus 205 equal to A upon B. Then 2 under 5 equal to A upon B, this minus 3. Then here under 5 equal to this 1 upon 2 into bracket A minus cross 3B upon B. Then A and B are integers. So 1 half 1 upon 2 into bracket A minus 3B upon B is rational. Therefore, under 5 is also rational. But this contradicts the fact that under 5 is irrational. Therefore, 3 plus 2 under 5 is irrational. Given that HCF 306 and 657 equal to 9, find LCM 306 and 657. Formula LCM equal to 306657 equal to A into B upon HCF of A and B, this formula. So here A 306, B 657 upon HCF of A means 306 into 657. Then 306 into 657 upon here given HCF 9, 3 and 9 4 into 657, multiply 22,338. This is the answer. Prove that the following are irrational. Number 1, 1 upon under 2. Answer. Let us assume that 1 upon under 2 is rational. So we can find co-prime integers A and B equal to not 0. So here 1 upon under 2 equal to 1 upon B. Cross under 2 A equal to B. Then squaring both sides. So 2A square equal to B square, number 1. Here 2 divides B square. 2 divides B square and 2 divides B. Reason, since 2 is a prime number and it divides B square, therefore it must divide B. Then B equal to 2C for some integer C. So squaring B square equal to 4C square. From 1 here 2A square. 2A square equal to B square means 4C square. So A square equal to 2 to the 4 means 2C square. Then here 2 divides A square, also 2 divides A. Reason, since 2 is a prime fact number and it divides A square, therefore it must divide A. Here 2 divides both A and B. Here A and B have at least 2 as a common factor, but this contradicts the fact that A and B are co-prime. Therefore 1 upon under 2 is irrational. Proof.